on today. Hi, welcome. I'm going to talk a bit about the Web Audio API. Has anybody of you guys already heard of the Web Audio API or used the Web Audio API? All of you. You should, because it's really, really cool. For those of you who haven't used it, I'll try to explain some of the basics. You can use the Web Audio API to create some sounds or create some effects and apply them to a sound. Today I will try to apply some effects which we will create with JavaScript to the guitar behind me. I'm going to do a live demo. Let's hope that works. So let me quickly introduce myself. My name is Bellen. I work for Made with Love, which is a song company in Belgium. I'm one of the co-organizers of the Frontiers meetups in Belgium, and you can find me on the internet as Samveo. So, I've been a musician kinda since I was a kid. I learned to play the saxophone, even though it's kind of blurry on the screen, but it's a saxophone. And I've studied music since I was about 7 years old. And I started with the saxophone, and later I grew older and I started getting into rock music, so I was like, saxophone is for old guys, I want to learn something new, so I learned to play the guitar. And when I had my guitar, I wanted to add effects to my guitar. Are there any guitar players in this audience? Do you know, is it familiar to you guys? I really like effects, but the thing is, they cost a lot of money. So I got interested in how they work, and I was like, maybe I can make this thing myself. So I bought myself a soldering iron and started making some pedals of my own. This is one of them. It's actually not a guitar effect, it's a synthesizer, but it's the same idea. And of course, the next step, since I'm a front-end developer, was like, it should be doable in a browser. I can type some letters together, make some code, and see if I can just create these effects using the Web Audio API. So that's what I'm going to try to explain to you this afternoon, just how to create some effects and apply them to my guitar. So is it possible in a browser? I hope so, otherwise I would look like a fool here. The first thing you need to do is get the actual sound of the guitar in the browser so you can hear what I'm playing through my computer and you can apply the effects in the browser. This is actually quite easy, but to get started, the first thing you need to do is create a new audio context. You can do this by just creating a new audio context and save the instance somewhere in a variable. And then to get this input sound, you can use GetUserMedia. Usually you use this to get access to the microphone or to the webcam. But connected my...
One moment, please. You forgive to check this.
I'm sorry. Perfect. So you can use this to get access to your microphone, but I've just attached this guitar as a microphone to my computer. So instead of listening to my voice, the computer will now just listen to the guitar, and you get access to your guitar in the browser. This is the way you used to do it, but the modern browsers have changed this API a bit, so now it's navigator.mediadevices.getUserMedia, and instead of using a callback, it just returns a promise. This only works in Firefox and Chrome. In Safari there is no GetUserMedia, I believe, but I think it's going to be in the next one. And Edge is doing quite well these days, so probably they have it as well. So once we have the sound of the guitar, we need to create an input node, something that holds this input and which we can use to work with it with the Web Audio API. So we create the input node using the audio context we created earlier. We create a media stream source node, and we just pass along the stream that we got from the GetUserMedia API. And then the last thing you need to do is connect the input node to the destination of your audio context. It's just saying like, I want my source and I want to connect it to the destination, aka my speakers. And that's all you need to do to get the sound of your guitar in your browser and hear what you're playing. I will demonstrate this later. Otherwise I will be switching from guitar and code and stuff. It's a bit annoying, so I will do all the demos at the end. Also, I don't like to play guitar in front of people, so yay. So, part number 2, the actual effects, because that's what it's about. I wanted to find out if I could create effects using the Web Audio API. And then the first one which comes to mind is just a simple volume effect, decreasing or increasing the volume. To do this, we can create a node called a gain node. Again, using the audio context, you do create gain. This will create a gain node.
and it just has one parameter that you can change, which is the gain or the value of the gain, which is your volume going from 0 to 1 or 0% to 100%. You have the input node we created earlier, you connect it to the gain node, then you have the gain node, and then you connect that one to the destination of your audio context. And basically you just make a chain of nodes, like input, volume, outputs. And this is how the Web Audio API works. You just create audio nodes and put them together, and in the end you'll get some surprising results. So yeah, this is kind of a basic sine wave, a fixed tone, and when I click these buttons you can see that I'm going to decrease the gain, and you will see that the wave gets a bit smaller. Like you can see, I can also increase the gain to 150%, and this does this with your audio wave. It just clips it at the top of the top and at the bottom. This is not something you want to do if you want to have a clear tone, but if you want to make your tone a bit more dirty, this is something a technique you can use to make your tone a little more guitar-like, dirty, rock metal, whatever. But we're going to talk about another technique for that later. This is the audio nodes I talked about. You have the input node connected to the gain node, connected to the output. That's all you need to do to have a volume effect with the input of your guitar. Next one, distortion. It's one of the most common effects you can use on a guitar. It's when you have an electric guitar and you play it, it sounds like an acoustic one, unless you have a distortion or a fuzz. It makes it sound more like a rock guitar or a metal guitar. It makes it sound like a guitar should sound when you play an electric guitar, in my opinion. So how can we achieve this effect? We can use a node called a Waveshaper node. And what this will do is it will shape your wave, your audio waves. It takes an oversample, which is just, it's not that important, but the most important part is you can add a function, passive function, which will modify your wave. Now I'm really bad in math, so I did not come up with this algorithm myself, but I found one on Stack Overflow. But basically this fancy math calculate curve is going to take your input curve, apply some math to it, and give back another curve. As you can see, this is again my fixed input sound, and when I apply the Waveshaper node, you see that the wave totally changes. That's what a Waveshaper does, it just shapes your waves. Again, input node, Waveshaper node, output node. If you want to add a volume in between, you have input node, gain node, Waveshaper node, output. It keeps on working like this. Throw all the nodes together until you have a nice chain, and have fun with that. The next node of the next effect I wanted to make is a delay effect. A delay effect is basically something you put on your audio and it will make it repeat and fade out in the end. And conveniently enough, there is a delay node. So what this is going to do, it is going to delay the playing of your sound. So if I would say, for example, the delay time is 1, it will delay my sound with 1 second. Now this is not really the effect I'm looking for, it's just one of the basic bricks you need to build a delay effect, because this is actually all the nodes required to make a delay effect. You have your input, we use a gain node to split it in two, we send it to a delay effect, which will send it to a gain, reduce the gain, the volume, send it back and forth until it fades out, and then the other channel just goes straight to the output so that you can hear your guitar. So yeah, it's not only the delay node, but it's a very important part of this effect. And then using some other nodes, you can create cool stuff. The next one is a flanger. Does anybody own a flanger pedal? Any of the guitar players? Alright, you're a cool one then. I do not own one, but I really wanted to try one, so that's why I decided to make this one. A flanger effect is basically going to put like a whooshy sound in the background of your guitar sound. You will hear it later, I'm really bad in describing the effect. But one of the nodes you need to create this effect is an oscillator node. An oscillator node is basically just going to oscillate and create a fixed tone, a fixed wave. And by default it's a sine wave. But you can change this to a square wave or sawtooth wave or a triangle wave. And then of course you can change the frequency from 0, which is the lowest and inaudible, to as high as you want. I think we can hear until 20,000, but if you have a cat and you want to annoy it or a dog, put it very high, you can hear it, but they will not be happy. So yeah, I will try to show you how these parameters change the wave. We start with a sine wave, which is a nice smooth wave, but then if you change it to a square wave, you can see that the shape of this wave totally changes to something square-like. A triangle wave makes triangles, and a sawtooth wave just makes something which you might see that it resembles a saw. Then, of course, when you change the frequency, you can see that the intensity gets higher and higher. And I can let you guys hear this, but it's a really annoying sound, so I'm going to turn this down. This is a sine wave, a square wave, a triangle wave, a sawtooth wave, and then when you decrease the frequency, you can hear your sound getting lower. When you increase it, you can see that it gets higher. That's what an oscillator node does, but we don't really need the sound of the oscillator node to create this flanger effect, we just need the wave of it. So as you can see, a bunch of nodes turn together as well, but we have the oscillator nodes right here, and it's going to just connect to the delay time parameter of your delay node. It's not going to connect to your audio source. It's just going to say, I want my delay time to vary based on my wave. So based on the value of my wave, I want my delay to be slow or I want my delay to be faster. Throw this all together, send it back and forth and up until the output, and you will get a flanger effect. And the last effect I'm going to talk about is a reverb effect, which is kind of like, gives a bit more character to your sound, a little bit of echo, add some characters of a room, like a big hall or a small toilet room. They all sound different. To create this effect, you have, conveniently enough, a convolver node. And what this is going to do, it's going to take an input response file, take the characteristics of this response file, and project them on your sound. So what we do is we load an input response file. I found one on the GitHub of Chris Wilson, which is a genius of Google, who has the web audio playground. You load it as an array buffer, then you decode the audio data, and then you just set it as the buffer of your convolver node, which you created at the beginning. And this will just take the characteristics of that input response file and project them on your own sound. So yeah. Looks something like this. Input, you have your convolver in the middle and send it to the output. So there's a lot of other nodes I'm not going to be talking about today, but you have an analyzer node which you can use to analyze your audio. Like you might have seen on my first slide, I had the wave based on my voice, on my microphone. You have a big quad filter node which lets you filter out some frequencies that you're not interested in. Channel splitter node lets you split your audio into multiple channels, merge them together. A panel node lets you position your sound in space, like to the left, to the right. If you have some digital audio Dolby shizzle, you can put it back and forth as well. And a dynamics compressor node compresses your audio so that there's not really a peak in your audio wave, that it's a bit more equal. All right. So I've shown you how to create these effects, but as you've seen, you need a lot of nodes thrown together to achieve some of these effects. So I started creating a little library called Audio Effects, which lets you do this. You just import the effects you want, apply them, create a new instance of them, and then chain them all together. And that way you can add the effects to your inputs quite easily. So let's see if this works. I really don't like to play in front of people, so that's always scary for me. And I have to mention that there is a little bit of latency between the time that I hit a string and the time you can hear it, so it's not that easy to play. So it might sound like I'm a bit retarded and cannot play guitar, which might be true, but we'll keep that in the middle. So I made this little application here, and when I select the input, turn up the volume, you should be able to hear my guitar, or not. There's just some shitty connection. Maybe the cable. Hey! Alright, there was a little panic. But as you can see, this is the first thing I talked about using the GetUserMedia API to get the sound of your guitar as a microphone and then just sending it to the output of your audio context, aka the destination. Now, if you add a volume effect, it's going to do what you think it does. It's going to decrease the volume, like, now I muted it. You can hear that it's much quieter, and then when you decrease it, it's much higher, which is not that groundbreaking, but a volume effect can sometimes come in handy. Now let's get to the real cool stuff. A distortion effect is going to make my stupid guitar sound like this, which you can hear it's a little bit more cool. it's nicer. There is some problem with the audio, but basically, yeah. You can make your guitar sound like a guitar should sound. Then if you add some delay, I'm going to turn this one off. This is what I talked about. It's going to just make your sound repeat a bit and then fade out in the end. So, like this. Of course, you can change the speed to some stuff and duration. You can basically configure the effect. You can tell you can choose how long it has to repeat until it fades out, how fast it has to repeat, and stuff like this. And then the flanger, which is this effect, which is kind of psychedelic if you're into that kind of stuff, which is totally fine. And you can hear that there's this wave in the background, which is the oscillator note, the sine wave, just adjusting the delay time of your delay note. And then, of course, you can do some stuff with that and get, yeah, really noise. But that's cool. Then the reverb effect is the one which is going to add a little bit of echo. It might not be audible, but there is a difference between having this and having this. You hear that it's kinda in a bigger room, or it looks like it's played from a bigger room. That's the convolver node projecting the characteristics of that input response file to my audio. The last one, I didn't show you how it's made, but it's basically a tremolo which does this. You all know this from the movie Kill Bill probably, because they have the famous song using this effect. I forgot how to play it, but yeah, you can increase it and they have it a little bit faster like that, play the right chords, and you have Kill Bill, and you can just pretend that you're an amazing guitar player. But I will tell you how this is made. This is basically just using an oscillator, the wave again, only of the oscillator, and just adjusting a volume, a gain note. So you're going to say to the gain note, I want more volume, less volume, more volume, less volume, based on that sine wave, and that's how you can create this kind of effect. Alright, so as you've seen, it's possible to create some of these effects. You can create a whole lot of more effects, and I'm trying to do this, but I need to find some time to do this. But as a guitar player, you're using your hands, so you cannot just stop playing to click on an effect or change some parameters while you're in the middle of a song. Luckily, there's a web-midi-api, which George talked about for a long time yesterday, but I'm just going to mention that it exists. And I built this, which is just some foot pedals, which you can just send some MIDI signals to your computer and then change some effects. Unfortunately, it did not fit in my luggage to come here, so I didn't bring it. But you can imagine that if I hit one of these buttons with my foot, an effect would be turned on or off. The web-midi-api is quite easy. You request MIDI access, you iterate over the devices you have available. You choose the one, I chose the first one, and then you just listen for incoming MIDI messages. Based on that message, you can do something. So yeah, now let's do an experiment. Since this is a browser, and browsers are cool to do stuff with a lot of people at the same time. I have made this little website, which some of you can go to. You can find it here, and you can add some effects to the guitar, and it will probably just turn out to be noise. But let's try it out. Before you go, let me quickly refresh. All right. Yeah, sure, sorry, I was too fast. It's here. You can all choose one effect and add change some parameters. Tell me when you guys are ready, or some of you guys are ready. Do you have people? Yeah, we do. We already have a few people. And so you guys can go crazy by changing. And I know that this does not sound good, and it's really just an experiment. But it's nice that you can let other people control the effects created by the Web Audio API, just using the stuff we know, JavaScript. So yeah. Do you want me to turn it on again so you can hear more noise? Okay. I think a lot of people are using the Flanger one and stuff together. It's not made to have a lot of effects at the same time. I'm not even doing stuff and it's still making noise, which is also cool. If you're into like experimental electronic music, this is kind of how you make it. You let just people do stuff. Enough with this. All right, so we use the Web Audio API, to create effects. We use the other stuff, like WebSockets to let you guys add effects and change effects. Where's my remote? Here's my remote. Let's see if I have something else to say. No, that was it. But I recently, somewhere last year, made another cool experiment, which is this. By using just the oscillator node that we talked about, I made an add-on plugin which does just this. I don't know if you can see it. Yeah. You can code and make your own music while you do this. It's the most useful plugin ever made, but I had so much fun doing this that I wanted to show it to you guys. It's basically just taking the key code of your key you're typing and then figuring out a frequency based on that, and that's how you get your own soundtrack while you're working. So yeah, my little audio effects library is on GitHub. The thing I used to create the waves is called oscilloscope.js. It's also on GitHub. This pedalboard app, I use this on my website. You can use this with any kind of input except your built-in laptop input, because the input of your laptop will create a feedback loop with your speakers, so you're just going to hear noise. If you have like headphones with a microphone, you can use your voice to create and add some effects to your voice, or attach any other musical instrument you want. And then the presentation is on GitHub as well. Thank you. Are there any questions? Okay. Yeah.
Thank you very much for your presentation. That was pretty cool. I noted that there is some delay between peak and actual sound. Does this delay make JavaScript unusable for real?
No, I forgot to mention that the Web Audio API runs in a separate thread. So it has its own clock, which is not based on the event loop of your just regular JavaScript. And all the things you do with the Web Audio API, all these nodes, do not delay your own main JavaScript thread. But if you add a lot of nodes on this audio thread, then you will get more latency.
Can you use this for a real music recording?
At the moment, depends on what you do. If you want to play live audio and you want to hear what you're playing, it's a little bit tricky because there's this few milliseconds delay which makes it impossible to play very accurately. But if you want to do experiments, it's perfectly fine for that.
Thank you. What about mixing? And I played with it a little bit and found that there is a limitation, at least in Chrome. How many different sounds can I mix?
How many notes you can... There's probably a limit. I have no idea what the limit is. Okay. I'm sorry, I cannot help you with this. No.
Thank you.
I just wondering how it would be to make, for example, a guitar tuner.
A guitar tuner, you can do this because you have the analyzer node, which will analyze your audio, and based on that and some algorithm, you can figure out which tune your guitar is playing. There's some cool examples on the internet. I don't know them by heart, but they exist. Yeah, I'm going to put one probably in this library once if I find the time, but it's a matter of just figuring out the right algorithm to convert the frequency to a note.
Question. Can I actually use web-midi-api to change my voice live?
Yeah, you can do that. Does anybody have a microphone, earplugs with a microphone, which I can plug into my computer instead of... no, but I need that stuff to put it to the speakers as well.
Yeah, you're right.
Anyway, if you want to go do it later, you can go to bellenboard.sambega.be, just plug in some earplugs, and you can add these effects to your voice as well. These are not really voice effects, but they work on a voice as well, and you can create your own effects for your voice as well, of course. Yeah.
So, thank you for the speech. It was awesome. What's about the export? Can I find a way to record it online through the browser?
Of course, you can record it. The web audio API has a lot of cool notes, and you just can create a buffer or a stream from the stuff you're doing, and then use a media recorder API or whatever to record the stuff you're doing. Yeah, the browser is really awesome. You can do everything with it, so it's possible.
Yeah. First of all, thanks for an awesome presentation speech. And another question. Your last example about the 8 plugin reminds me about all those people who use live coding. So, do you know about any JavaScript live coding environments for music except I've seen one guitar that's installed?
Yeah, there are a few cool audio projects. Oh, there's a lot of audio projects, and there's people who make audio editing software and everything on the web, so yeah.
So can you recommend one?
Excuse me?
Can you recommend one?
No, I can tweet you one later, but I'm really bad in remembering names, so I will tweet one or a few later if you want. Okay? Okay?
So it's very few questions there. So this latency issue, it's like web audio related?
Excuse me? What?
Latency.
The latency, I think it's web audio related, yeah, because I have this external audio interface which would take away the latency between the guitar and my computer. So it's just the JavaScript which is not fast enough to process all these calculations on the audio waves in real time, or just not fast enough.
One more question. So when you record this, any way to use it with now, W, some application which you manage audio? So Ableton, for example, when it's something like this,
I did not understand, I'm sorry.
Or you draw anything?
No, I didn't understand. But we'll talk after it and then we'll discuss about it. Is that fine?
Yeah, sure.
Okay. Is there somebody else who has a question? Or was that all? Yeah, no? Do you still have time? I think I still have 5 minutes. I just remember that one time I started making a synthesizer using the web audio API. Maybe that's something cool to show if you guys are interested. Let me just think where I put this. Oh, right. So, crap, it does not fit on here. But what this does is it's just a synthesizer which you can just play some tones, but you also have some LFOs, which is going to make your stuff sound like more wavy again. And then you're doing all this stuff. It's still a work in progress, but using the Web Audio API and some creativity, you can really do a lot of cool stuff. So that's it. This is really it. Thank you very much for listening.